Okay, we are talking about things to do with dates. I am a bit subdued because I have a cold today, uh, but we will see what we can do. Okay, we are talking first about date interval.
There is a featureized ref page for it.
And these examples will also evaluate in prototype builds if you have one.
Okay. Great. Let me start a prototype build. That's really weird. Look at that striation of that button.
Yeah, nice little rendering artifact, it looks like.
Oh God, this error here, this specified font color error, that's been there for like 3 months. Do I need to, who's PMing here?
That's me, Devin.
Okay, can you go kick the front end team and just say, get rid of this message? What is it?
Yep.
It's been there for like 3 months.
Yep.
We should be able to get rid of it. Okay. Background noise. Somebody should put themselves on mute, whatever.
This is one of the two objects we are working on, the other one being the array, data array.
Okay. What is data array?
So that would be a collection of data objects, a bit like the relation between quantity and quantity array. It's not there yet.
Okay.
So we are reviewing only, but just to show the fact that there is a difference between those two.
Okay. So this can be a multi-interval there. This thing here.
Right. Following interval itself.
Right. Oh, please don't do that. Please don't ever do that. Don't do that. Just list them here as well. Okay?
Yep.
Okay.
Excludes the final instance. And the granularity. So the start and end dates can have their own granularities, right?
So they can have their own granularities as input, but the date interval itself has a canonical granularity. It's either, all instants between those endpoints, or it can be canonicalized as all days between them. But you can have a start point that is an instant and an endpoint that's a day, and we basically canonicalize those to the representation of the interval's granularity.
No. But you got to do something by default. It's got one argument, right? What do you do by default in that case?
If it's got one argument that's a granular date?
No. You've got one argument. The start is an instant. The end is a day. What do you do?
So our default behavior is that if you don't specify a granularity, otherwise we say the granularity of the interval is instant. It's all instants between those points.
I don't think that's right. I don't think it's right. If you've got two start and end are both days, right? I don't think you want the instant from midnight to midnight of those days, do you?
So right now, we have many functions in the system that takes like a specification of one date to another date, and they interpret all of those as instants. So our thinking was, what are those functions going to do if suddenly we force them to say?
Well, what's an example of such a function?
Something with a data, for example. What would be an example, Nick?
Yeah, I mean, any of the data lookup functions have
Like what?
So weather data, financial data, the entity value functions use a date, a start date and end date, and are inclusive of all points between there. You can also explicitly specify a step size for sampling, but
But that's kind of wrong.
Yeah. And there's a difference between what a date interval represents and an explicit date range specification, but they're closely related.
Yeah, but date range with a step means sample it at many possible steps.
Right.
So the granularity of date interval you're saying represents the collection of days between those two start and end points. Is that right?
Yeah, it's the granularity of the dates contained in that interval. So if even
no. So for example, let's say I say date interval of now minus 3 weeks to now, granularity of days.
Mm-hmm.
Okay, now how do I get the explicit days within those times? How do I break the date interval into its granular pieces?
So there's a property right now of that date interval that if you said % open bracket dates, it would give you.
No, that's not what I want. Yeah, I want the actual granular days, the list of days.
Yeah. So
right.
Right. I don't think we have prepared anything for that, but this should interact well with date range, probably. Date range of these should.
And duration of %1. What the hell is that? Well, that obviously should work, right?
Yeah, that's a hookup we haven't done right now. There is a property for duration.
I can see that, but that's not good enough. I am not at all convinced about this thing. I'm sorry. So you're saying date range, which normally gets as input date 1, date 2 in an increment, right?
Mm-hmm.
So if I say this what the hell is that? Oh, I see. Now minus. So that's the instant there, but I don't understand. Oh, that's the step. But what about the granularity?
So for date range, the granularity is determined by the start date. So
okay,
if you
so
said
if I
today,
say date object,
if you said
okay,
today,
so if I
today now, it should be days. Yeah.
Okay. Okay.
And in principle, a date range could just consume a date interval object that would have the start and end and granularity by default. Need to do.
What default? I mean, if the granularity by default is instant, then obviously it can't evaluate.
Right. Yeah, I mean, so the tricky thing about having a granularity in the date intervals is that we don't necessarily want the behavior of the granularity to be super strict in terms of we don't want a date interval that has a granularity of days to reject comparisons with other granular objects because it just wouldn't be very useful. So in some ways, the granularity is a sort of abstract or like a recommended sampling rate or a meta information about the range, because it ultimately can boil down to there's a very first instance that's included.
Why didn't that work?
The comparisons were broken recently there because I was tweaking some things, but it would absolutely work normally.
Okay.
It works with date overlap skew and date within queue and interval operations right now also, but there are ambiguity problems with if you said, is that interval less than 4? For example, we worked with with Rob some time ago about getting interval comparisons to handle those cases.
Well, but it won't evaluate, right?
Right. Yeah, it wouldn't evaluate. In the same way that if you said, is today less than now, we don't evaluate it, and we give a warning message that says you're comparing dates of unequal granularity and the result is indeterminate. Now, that shouldn't be typesetting that way, but
Yeah, well, it's goofy. I mean, this stuff is horrible.
Yeah.
Yeah, we definitely don't want all this crap there.
Mm-hmm.
Somebody's asking if we can display dates as analog clocks. I think we can, can't we? If you feed one of these data objects into one of our clock things, is that not correct?
Yeah.
Clock gauge.
Clock gauge.
Amazing. I didn't actually know that worked.
Mm-hmm.
That's cool. We should put that example on the. It's certainly in properties and relations on the data object page.
Objects. Yeah.
That's actually really cool. Okay. All right. So let's look back here. What is this? Default categorization. I don't understand this. I just don't understand this. It just seems wrong to me. If you have a date interval, look, it should be August 31st inclusive, which means going to, the instant before midnight on the next day. Shouldn't it? I don't understand this.
Yeah,
It just seems completely wrong.
That's the question there about in terms of if you're specifying date lists, do we handle them in the same way the date object does, where we infer the granularity based on the length of them? And for the left-hand side, we go to the first moment, and the right-hand side, we go to the last moment, which is, it sounds like what you want to do.
I think so. But I mean, how do we get to that last moment right now? What's the function that does that? Given a granular date. Go ahead.
Yeah. So right now we don't have a exposed system function. It's one of the items that's farther down, is if we should have a last date function or an argument in date bounds that lets you extract the last moment or the last object of a given granularity from an existing date.
I think we should, but I think it's a slightly obscure thing. So,
yeah, so date bounds currently doesn't do subsampling from within granular objects. So you can give it a list of dates, or it will get bounds out of containers like time series or data bins.
I see. So if you gave it a single object, a single granular object, then in principle, I mean, here you could give it a granularity. You could give date bounds a granularity and ask it. Now, I don't quite understand what the instant that is right before midnight is.
Right. There's an open and closed right-hand side problem when it comes to instance of how we want to handle, what is the last included instant of the day.
In the case of interval, max of an interval is the right-hand end of the interval, right?
Right.
The problem is, I mean, it's basically midnight minus epsilon, and that's hard to specify.
Yeah.
Okay. Well, let's keep going here. Yeah, I think this data interval form is okay. I think this is kind of not, these data intervals are complicated, and I don't think we should try to do this.
Okay. Yeah, I think that generally makes sense.
Why does it say calendar granularity? It should say granularity.
Yeah, we
Hour.
can we've generally been referring to calendar it isn't as pertinent for hour, but because the granularity of the date is inherently tied to the calendar type, when we refer to granularity for clarity's sake, we often try to reference calendar granularity.
That seems completely crazy for hour.
Yeah, I think for hour, minute, and second, it isn't relevant. Yeah, it can probably be shortened there to just granularity.
Meaning is less obvious. Through in this case for days means you're going to get to the end of that day, right?
Right. So Monday through Friday includes Friday, but Jose and I have sort of gone back and forth on this. I feel like,
is the until meaning it stops at 11 p.m. or does the until mean it goes through the hour of 11 p.m.?
Yeah. So the object that you're looking at right now says through, and that means it goes through the end of 11 p.m. If we were to say until 11 p.m., my general interpretation of that would be that it stops at 11. If your business hours are 9 a.m. to 5 p.m., you can't show up at 5:30 and expect to come in. But I generally don't really hear a lot of common usage of, when you're talking about fine granularities of hour, minute, second, of someone saying through.
Yeah. No, I agree. I mean, it wouldn't be through 11 p.m. It would be through the 11th hour, so to speak.
Mm-hmm.
I think my suggestion here is that for hours and minutes and even seconds, we should show the last instant, even if it is granularity hour. So we say.
How can we show the last instant? I mean, colon 59 or what?
No. From 17th 1200 to 18th 1200.
Yeah, and if we
see.
Just
hours
say that,
from midnight to midnight.
Yeah, and I think if we did that, we would probably change the label from through to until, just to make that pretty clear.
Yes. You mean the display here?
Yeah, the display of it.
But in the internal form, what would it be? Would it go to 11 p.m. in the internal form, or would it go to?
So our current version of the internal form says for non-instant cases, because instant's its own hairy problem, both endpoints are included and they go out to their full bounds. So the input form right below that goes to 11 p.m. and the internal code knows that because that is an hour granular object, that includes all things that happen within 11 p.m.
Someone on our live stream is asking whether data objects can be made faster. Yes, that is a big effort.
Mm-hmm.
That's part of this project, is to make them faster.
Yeah, we've been migrating and optimizing code as part of this, but that's a general umbrella project to streamline things and to generalize the handling of things like time zones and calendars also.
And data array is also the object that will handle many data objects.
Yeah, which will be a big help for temporal data.
Someone Truth on the live stream was complaining that this doesn't work in the cloud. I'm not surprised it doesn't work in the cloud. I think the cloud refuses to let itself be interrupted that quickly. But it does seem to work here. I don't know what the one is. Well, who knows what that one is, but anyway, that seems to work. Okay, so back to this. Well, I mean,
so I guess my general question would be, is it confusing to have the language switch between through and until handling the endpoints? And if so, should we just have everything always be implicitly open on the right? So the full form is always showing the first.
No, that's going to be super confusing. I mean, I think the print form, the thing that is confusing here is that the print form is going to display a different date than what is there internally. Right?
Yeah.
So if we say the min-max, so in the case of up to midnight, okay, so if I say this, okay, so now I say that thing max. Okay, now I'm totally confused.
So that's the granular hour, because the date interval is an hour granularity.
Okay, then the only way you're going to do this is to say 11 p.m. to midnight for that granular hour.
Mm-hmm.
I mean, if what we did for a granular hour was to display that as 11 p.m. to midnight, I think we'll be okay.
Okay. Yeah.
I mean, in other words, the hour is a weird case because a minute,
Right. You wouldn't really say from 11:06 to 11:07.
No, you wouldn't.
Pretty
I mean,
clear what
if you
11:06
say, so let's look at these other ones. Okay, so for a day, you wouldn't do that either. We understand days. A day means the whole day inclusive, right? The problem is that for whatever reason of human experience or something, hour doesn't work that way. So that a granular hour really needs to be 11 p.m. to midnight. Does that make sense?
Yeah.
So if we did that, if the general print form of a granular hour contained that, I think we would be in good shape over here as well.
Right. It's sort of like the typeset form for our centuries will show the start date and end date. So if you said current date century, I guess that says the 2000s.
That's crazy. What's that?
Oh, I was just saying for date object itself, but yeah, that.
Oh, okay, wait a minute. But so you're saying current date of century.
It's sort of the general version of it, but if.
Yeah, that's a weird case, right? Because I mean, it's the we really decided to put the apostrophe there.
Yeah, that's what we went with to clarify that it was the 2000s and not just referring to the year 2000.
No, I understand, but the question is whether the apostrophe should be there or whether it should just be an S at the end. Did we ask DQA about that?
I don't recall offhand, but I can check.
Let's check that. It looks probably wrong to me, but we may have decided this because of some consistency with some other case. I mean, both things are used in the world. I just think this one doesn't make a lot of sense because in English that tends to be a possessive form, which this certainly isn't. Okay, but anyway, so backing up to the hours idea. So we're saying a granular hour becomes something which is displayed as 12, usually it will be 1 to 2 p.m. But sometimes if it goes across the AM PM marker, then it has to say it differently, right?
Yeah.
I actually like that. Are there any other ones we have to worry about that with? I mean, seconds and minutes, you don't have to really worry.
Yeah, we've always ended up having to have custom typesetting for hour just because.
Well, actually, week, you have the same issue, right?
Mm-hmm.
What do we do for week?
So right now we say week beginning. So if you did current date week, say week beginning Monday, we don't typeset it as Monday through Sunday. And if you do week beginning Sunday.
Well, I mean, we could obviously do the same thing for hour. We could say hour beginning, but I think it's more obscure.
Yeah.
I mean, hour beginning would certainly make it, actually do the right thing.
Mm-hmm.
I think I actually prefer that to avoid a confusion with the interval, because from 2 may suggest this is an interval.
Fair enough. Yeah, I mean, I think granular hours is a weird thing anyway, and I think this is a reasonable way to handle it. Fine. So if we do that, then how would we represent this? Because this is now saying that's an hour granularity, but it doesn't explicitly say hour granularity.
Mm-hmm.
I mean, we'd end up with beginning of that hour. Beginning of hour beginning this.
Something we could do is to move the granularity to the first line, show 3 lines. So in the same way that for granular date objects, we do show always the granularity. We could show it for date intervals, and then it's granularity hour from 2. And the from and to are 2 instants.
Possibly.
Or we could have the granularity be part of the label. So hour beginning, instant beginning, year beginning.
That's fine. I don't think we need to say instant beginning. I think we just say beginning.
Yeah.
Right.
Bob on the live stream is asking about Chinese years. We have those, don't we?
We don't have the Chinese calendar fully integrated. There are some complications with the way that the cycles are built into the Chinese calendar. We have a prototype version that we have, and we have some internal versions used for like holiday calendars, but there's a larger calendar project to expand what we have that includes some core functionality and some things that may be part of summer intern projects, just to flesh out, that adding support for the Mayan calendar isn't a super high computational priority, but it's something that's pretty modular that could be done by.
Yeah, okay, fair enough.
Yeah.
Okay. Be nice to have, but probably not of the Mayan market is modest.
Yeah, and some like the Japanese calendar don't have real good canonical forms. Like there are plenty of internal ways to represent it, but having eras as sort of a string precursor to a date list is a little weird. So some of those require some design, and some of them are
okay. All right. Okay. By the way, someone on the live stream is asking, is this related to temporal logic? Yeah, it is related to temporal logic, but I don't know what's happened to our temporal logic project. What has happened to that?
So Yang was working on that, but since Christmas, he became very busy with his studies, and then some family issues during the summer as well. So, but he wants to come back as soon as he can.
Okay, but do we have a design that wasn't crazy for that?
Well, what we learned in the last meeting we had with you is that you had a larger idea of what temporal logic is. So we were focusing on what is usually called temporal logic, which is the modal logic applied to time.
Yes.
And for that we had a design using the standard words like until and etc.
And what was my generalization of that? I mean, I wanted it to be concrete as well as be symbolic. Yeah.
Yes, but I think you had an interpretation of temporal logic that included not only the logic part, but also the interaction with date intervals and other things. So the thing we presented you was a pure extension of Boolean logic with just a few more operators.
Yes, I see. But we need to concretify that by actually being able to say until and then a date interval and things.
Exactly. Yes, that was the part we hadn't done yet. And then we were exploring the literature, and indeed there are extensions to include these things, but we didn't have that yet.
Okay, fair enough. Okay, what am I looking at here? Is this, what the heck?
So just a basic overview that the same sort of arithmetic operations that work on dates work on date intervals as well, and we handle interval results in quantities as quantities with interval values.
Say that again. Handle what?
Yeah, I mean, basically, if you are taking the difference of a date interval to either another date interval or to a specific date, the result is a quantity with an interval magnitude.
I see, because the date, because it's a difference, like with degrees, like with temperatures, it's no longer a date, it is a quantity.
Right, yeah.
Okay, makes sense. So I assume that I can put dates into an interval and it will turn itself into a date interval. Is that true?
That's. I don't have that fully hooked up right now because there are a couple of fringe bits of functionality that use that notation for something else. But the intention is that interval of date objects will canonicalize to a date interval. And so things like I hooked up an interface with timeline plot, for example, so it understands date intervals.
Wonderful. Do we have a design for what the actual timeline looks like there? Or do we already have that?
Yeah, we already have that. So like, we basically have our two endpoints in a line running between them.
Oh, okay, fine. How is that represented in the input to timeline plot right now?
So timeline plot does support a interval of two date objects to represent that.
Okay, fine. Okay. So I don't think we need date interval Q. Let them read the head.
Yeah.
My feeling is it should probably let itself be given as a blob of the first two arguments.
Mm-hmm. Yeah, and our general paradigm is that any function that needs to reduce either a granular date or a date interval or something that's sort of an extended period of time to a specific moment, the canonical way we do that is we take the first moment. So if you say date list of a date interval, we can't really give back.
Right. So you're proposing that we have first date and last date.
Yeah, and it would be particularly useful for date interval, but it could be generalized to work on granular date objects or from as a convenience on time series or data bin. And having a
one thing that I don't like is the word date as opposed to time here.
Mm-hmm.
But I mean, we've kind of, with date list plot, I mean, it's kind of ugly because some things are thought of as times, some things are thought of as dates.
Yeah.
I mean, dates are more common, but...
Yeah, because we also have time object. I think we are trying to move away from time to date and consider date as this more general object.
Well, I understand that.
We also could say min date, max date.
Yes, I think that makes more sense. Because min and max does min apply to a date interval?
Yeah, it does right now. So in the same way that it works on an interval.
So why don't we just use min? Why are we introducing a new function for this?
I think the main thing would be if we want to specify a granularity to extract. We could just add that functionality to date bounds, and then you just say first or last of date bounds. But
well, wait a minute. Well, the granularity that you extract, if I want to change this, I can always say date object of that, comma, minute, can't I?
Yeah, you can, and that will change it. But there's a difference between taking. So if I have a date interval that represents this month, and I say I want the maximum value from it, and it is.
I understand what you're saying. The maximum value, the maximum day is the last day of the month.
Right. If I then say hour, it will go to the first hour of that resulting date object. But if I
opposed to,
yeah. So it may be a bit of an edge case, but there's some case for we have internal tools that do that sort of extraction.
I think it makes sense. Max date, min date makes some sense with a granularity. And having granularity for date bounds makes perfect sense to me.
Okay.
So that's saying within that date interval, give me the first hour and the last hour within that date interval.
Correct.
Okay, sounds good to me. All right, now we go into null infinities and all this kind of stuff. Just wait until we actually have proper general relativity implemented in this.
Yeah, Itai was giving me a hard time about what nature of infinite future and infinite past are we talking about?
Okay, what is this for?
So we initially had looked at the idea of infinite future, infinite past as being useful in a date interval, saying,
Yeah, forever.
forever.
Now and henceforth.
Yeah. And when looking at hooking that up, I thought it would be potentially useful to have infinite dates as standalone results. So we could have a date object that represents the infinite future. Or
I don't see why not. I mean, that seems like a useful thing, because if you want to say I'm thinking of computational contracts, right? From here on forwards until the end of time.
Right. And initially, when I was looking at them in date interval, I had imagined infinite future and infinite past would just be inert symbols, but having them be a canonical form of date notation where you have a date object that has a first argument that is infinity means that we can expand that to work in the larger date framework. We could have absolute time give a directed infinity value.
And what's the eternity thing?
So that's the granularity, because we didn't really want the notion to have date object of infinity comma instant. There isn't really a granularity associated with an infinite future, infinite past. And it also helps distinguish the form of it. It's essentially the largest possible granularity you have.
Okay, let's do a little physics discussion here. Okay, remind me, Jose, how this works. I mean, the notion of infinite future, infinite past in the general relativity setting. All these script, whatever they are, future null infinity, past null infinity, all these kinds of things.
Yes. So the idea there is a bit like our directed infinity. The fact that because we are in a four-dimensional, but we can think of two-dimensional space in time and space. And then if we say the light rays move always in 45 degrees, so do they go to the infinity, which is directed vertically in the time direction, or the space direction? And then it was invented that they go to their special infinity, which is null infinity.
Because for a zero mass particle, there's no passage of time.
Yes, so that's a consequence, but more importantly is that, this is done through what is called the conformal transformations, right? In which they try to bring infinity at a finite distance. And when you do that, you end up with this type of diamond in which you have future infinity at the top, past infinity, and then you have the spatial infinities on the sides. And the lines between those points of the diamond are null infinities, which are the places where the light rays go.
Right. But the light rays have this weird feature that they don't have any notion of the passage of time.
Correct. Yes. Yes.
Okay, so let's understand that for our purposes here. Okay, so I'm just thinking, gosh.
I think that this is our description of the time axis, the vertical axis. So for us, these infinities are the time infinities, the future infinity and the...
Okay, but you know what? When we do spatial logic, we're going to want a spatial infinity as well.
Yes. Yeah. So this would be like in the same way that we have infinity and directed infinity and complex infinity, etc. If we happen to be at some point doing these various things, we will need a way of distinguishing these possibilities.
Right, but so in particular, a ray versus a finite line segment, right? What is the end point of a ray? Don't we already have that in the computational geometry stuff, where you can have an infinite coordinated array?
We have the infinite lines.
Right, like a half line.
Right, and the half space, I think it's called.
Okay, but so that gives a vector. This is 12.1 getting itself confused. What is going on here? Well, oh, there we go. Finally came through. Okay, represents a half line. Okay, in that direction.
Mhm.
So in the spatial case of this, yeah, okay. So in the time version of this, there is a notion of a half line, which is what you're giving here from now until infinite future, right? That would be an example of a one-dimensional half line, effectively,
Right.
in the time direction.
Yep.
And I guess my question is, I mean, is the right thing to have an infinite future, or is it to have which is not what we do in the spatial case, because in the spatial case, apart from directed infinite, we don't have a way to say where in space, right? In the time case, because it's one dimensional, right, we only have to worry about, there's a well-defined plus infinity and minus infinity.
Right. And
Right?
in the complex space with an angle, which is what we do with directed infinity, is enough.
Yes, I understand. But so my question here is what we want actually infinite future, or is it an interval from now until the infinite future? Or is that best represented as just a date interval from now, comma, infinite future?
Right. I would separate the point infinite future and infinite pies from the interval, which goes from some point to infinite future.
Fair
Because,
enough. But okay, so fine. So what you're saying is like now to infinite future.
exactly.
Okay, so what the heck is this thing? Calendar granularity is instant. I don't understand that.
So that's the collection of instants from now to the infinite future.
Okay, so if I say the max of this, infinite future in GMT minus 4, that doesn't
Yes,
seem right.
I'm not sure why it's appearing there in what Nick has on the left. It doesn't appear, but
Right, well, so that shouldn't appear, obviously.
right.
Right. Yeah.
I think it's important to distinguish the actual data object of infinite future from intervals that go from somewhere to infinite future, potentially even
Fair
from
enough.
minus.
I'm sorry, we've got %19 duration. I want to know what that is.
Yeah, that's probably. Yeah, it's not fully integrated at this point, but
So what should it be? Should it be an infinite quantity?
Yeah, for sure. Now the
Yeah.
unit is more debatable, but should be an infinite quantity.
Do we have infinite quantities? Do they work?
Yes, I think so.
Okay, so if I say quantity infinity seconds, for example, okay, and if I say 1 over that, apart from the weird spacing, which is definitely wrong there and should be fixed.
yeah, I'll look at that.
Okay, so we do have infinite quantities. All right, so the only question then is with the duration here,
I would say if there was a granularity originally, we keep it. If not, we say seconds. Which is the fundamental unit of time.
yeah, I mean, look, if this is being used for human purposes, years is going to be more relevant. As in, if one's writing, this, let's say one's writing a contract and one says, on such and such a date, the, I don't know, somebody's, I don't know why I'm thinking of something silly, like somebody has, given a donation to a university on the condition that on October 10th every year they put up some weird thing in the quad or something. Who knows? But that contract basically says from now for an infinite number of years. I don't know. It seems more natural than seconds. Seconds seems more scientific, but I can't imagine this is going to be used, that the infinite future is going to be used for scientific purposes here.
Okay.
Um,
It's true that when we have only the infinity, as we see on the left-hand side, we put infinity in the years because it's the shortest representation.
sorry, where is that?
Yes, on the left-hand side notebook you have.
Yeah.
There you see that infinite past is represented as a single list.
I see. And which means it's in the year element of the list structure.
Exactly.
Okay,
It's
let's talk about the
canonical.
granularity of eternity.
Mhm. Yeah.
Why?
Because we have larger granularities. It sounded, I mean, it has to be years at least because we put it there. But it
No,
sounded
I understand.
strange.
What does it mean that the granularity is eternity? What does that mean doesn't that mean that it eats anything else, that the eternity granularity is just like,
Yes.
so how does that work then?
Yes, when we do arithmetic with different granularities, the biggest one wins. And so because this is going to be bigger than any one.
Well, that makes sense. Otherwise you get goofy things with infinity plus 7 years.
Exactly.
I see. So that's basically saying, okay, what's the answer to, okay, so infinite past, infinite future minus infinite past should give, okay, it's an error right now, but it should give, what should that give? That should just give an infinite number of seconds in an infinite number of years.
Exactly, plus infinity years. Yeah.
What bothers me here is I could imagine, see here, this could be almost read as an infinite number of eternities. Right? Explain to me why that doesn't mean, oh, I see, it's a granularity. That's where the starting point is an eternity away. Its starting point is not, it's not granularized to years, for example. I think that makes sense.
Yeah, I mean, because the first argument again is still sort of the year argument of the date list. When you have date object with a granularity of century, we don't change the date list representation to suddenly the first argument means centuries. It's still years, but it gets abstracted out to be a century. It's sort of a expanded granularity in the calendar.
All right, let me just ask a couple of questions here about the physics case. So when we start doing stuff in astro coordinates,
Right.
okay, where we have to have retarded coordinate systems and all kinds of weird things like that, how will this be affected here? I mean, so in other words, the position of Jupiter or something is, how will that work? What will we do there?
In relation to infinity?
No, I mean, in general, I'm just trying to understand, because then I'm going to talk about infinity in a minute. I mean, I'm just trying to understand, what does it mean? Because clearly the simultaneous, right, you understand what I'm talking about, that we have to have the state of the solar system, for example, at a given point is unmeasurable.
Right.
It's only the retarded positions that are measurable.
Right. So the key thing there will be a concept that we don't yet have, which is the time system. So together with the calendar, which is some sort of the coordinate, we will need something called time system. And there we will have things like solar time, atomic time, UTC, time measured from the center of the solar system, time measured from the surface of the Earth, time measured from the barycenter of the Earth.
And so that then will be retarded time. So that in a time system, there's also a location. And
exactly. Yeah.
And
so you have to fully specify the method you are using to measure time.
I understand, although typically that will be a light signal from wherever the center of wherever you say it's measured with respect to. Is that true?
Well, here we have to be very careful with the measure of time and the measure of durations of some process, which will be quantities.
Okay.
So some things here will be, again, data specifications in which a time system will specify exactly how you measured it. And in other cases, we will be dealing with quantities.
So wait a minute, let's be practical. Okay, so what is, I don't know, what's the time delay for a signal getting to Mars? Like 20 minutes or something.
Right.
For the moon, it's like a couple of seconds. So now the question is, we say the spacecraft landed at such and such a time,
Right.
right? And so that is with respect to a time system. We can give that as a time system centered on Earth, in which case the actual time on a clock on Mars will be 20 minutes earlier or something. Is that true?
Right. And there we will have to be very careful because, for example, imagine a space rocket which is at the same position of the Earth but moving in a different direction. Then it will not have the same time as the Earth. So positions is not the only thing that matters here. Velocities also matter.
What about accelerations?
As well. I mean, velocity is the fundamental thing. We can say that we have to measure the instantaneous velocity, but yes, acceleration also plays a role.
Oh, but wait a minute. How does that work? So, I mean, if you measure the instantaneous velocity, you have some relativistic time dilation.
Yes.
Some gamma.
Yeah.
But the gravitational field, this is a mess. My gosh.
It's complicated, but the important thing is that the information can be all placed in the time system. So remember, this is a bit like in geo, we have the projections and the datums. The projections are the coordinates, the datums are the specification of how we measure things. So here we have the equivalence of the calendars, like the projections, and the time systems, like the datums.
Explain that to me again. So datums give you, I mean, like a particular datum tells you like how high you are relative to the nominal surface of the Earth.
Well, a datum is, for example, a reference system, like the 3-axis from which you are going to measure things.
Yes.
Right? And you have to give an experimental method to say how you are fixing those 3 axes. And
I see.
that once you have these 3 axes, you can start saying, now I'm going to use spherical coordinates or cylindrical coordinates or Cartesian coordinates.
I think I understand, although I think it's a little bit more complicated, right? When you have given that you're explaining that not only do you need to know, I see, but the time system is actually a space-time system, is it not?
Right. So the time system needs to have specification. That's why you have to say something like, what is atomic time? Atomic time will say we are measuring time with atomic clocks situated at the surface of the Earth from this exact date. And then that's a continuous counting of seconds, no leap seconds or anything there.
And the rate of those seconds counting will be affected by gravitational redshift and things.
Well, for each clock, the rate of seconds is exactly the same one. But of course, if you place those clocks in different places, when you compare them, then
right. But in the surface of the Earth versus in, away from the gravity of the Earth, right, there'll be a different rate.
Yes, when you compare them. What I'm saying is that the physical atomic clock works in the very same way everywhere. Just that when you compare them, one has been floating in space and then comes back to Earth, then it's when you can appreciate the difference.
All right. Is this relevant to what we're talking about here? You think
not really, because it will be when we introduce time system, which will be
I know. I'm a little worried about the interaction between time system and infinite future. That's, I guess, what I'm poking at. Because time system, you see, this is going to get into this null infinity nonsense. Because what's going to happen is infinite future. You see what I'm saying? Infinite future here. I'm confused. But
well, our infinities here are the time infinities. If we ever need the null infinities, we will have to introduce new concepts for them.
Yeah, okay.
So it's the same thing as our infinity and complex infinity. Right? So they are different concepts and they have different. And then at the end, they all go to directed infinity, which handles the mix.
We have various comments on our live stream, and then we should wrap it up here. Yeah, mathematical musings is saying this is about Penrose diagrams. Yes, that's what those conformal transform things are. For infinities in 3D space, would you need a direction to? Yes. Okay. Okay. Sandra is saying date difference of date 1, comma infinite future could have the same units as the granularity of date 1.
Could they'd be equivalent since it's an infinite value of time units, but
No, I understand, but that's what we've been discussing is whether the quantity. That's not unreasonable because that at least gives you the opportunity.
I think I agree with that. It's only in the cases in which there is no granularity floating around. We only have eternity that we use years.
Fine. If it's infinite past to infinite future, then we have to use years.
Right.
Yep.
Yes. Someone is commenting this is like a philosophy channel. Yeah, well, the thing that's always fun with this stuff is in order to actually get this stuff right, you have to go pretty far out there sometimes in philosophy, physics, whatever. Let's see, but it's like quantum value. Okay. SWSH is saying space-time event as a way to wrap geoposition and data object together. Yes. What is our way of doing that? We have because we have that for these.
Yes, geoposition can handle lists of 4 arguments, and then they are space events, and you can extract the data object from there.
I understand. Yeah, I mean it has an absolute time specification as its fourth element. I mean, I agree that once we get into stuff in the solar system and so on, I suspect we're going to end up with things more like space-time events because geoposition is a very bizarre. Well, it may end up being
The plan is to have an astroposition, which takes care of coordinate systems and this frame specification.
Fair enough. When are we going to deal with the UTC problem?
UTC is a time system.
No, I understand that, but what is our plan for dealing with the glitches in UTC relative to whatever those other things are?
Leap seconds. So that's in the plans. So perhaps after data array, it will be our next big thing for time, because we will need it for astrophysics, for astrographics.
Right. Fair enough. Well, we'll be ready for when the when there's more going on in space, we'll be ready. And we won't get it wrong, knowing that what the I mean, I don't even know what people. I mean, right now, when we say, and I don't know whether we have this data we say the landing time of such and such a spacecraft, right, on Mars, for example. I don't know whether we have that to the hour or minute, but clearly that is in Earth coordinate system, isn't it?
I guess so, but these things, as sometimes is stressed, have an indeterminacy. Like, it's this famous question of if the sun disappeared right now, we would take 8 minutes to notice it. So when we compare our times with the time of the sun, there is this.
Sure, but I mean, but when I say, look, when it says, Apollo 11 touched down on the lunar surface at this particular second, my assumption is what we quote for that is the second in the Earth time system.
Yes,
time system of the Earth.
Yes, but there is this assumption of a mechanism to communicate both places via light ray, and then you take the midpoint and things like that.
Why do you need the mid? I mean, I'm just trying to ask. When we have data that says this spacecraft landed on Mars at this time, right? Is it the time at which a radio signal to Earth recorded that the spacecraft landed, or is it the back computed time in some Martian coordinate system?
Well, I think it's a time measured from Earth, but removing what you were saying before about retarded time, removing the distance, the time, the distance corresponding to the time. No, the other way. Removing the time corresponding to the distance to them.
Okay, so what you're saying is, if if you watch the live stream of the spacecraft landing on whatever, right?
Mhm.
Then everybody cheers in the control room or whatever at time at 15 minutes past midnight on the Earth,
Right.
right?
Mhm.
But then that the time that we would record for when the spacecraft landed on Mars would be 11:55 p.m. the previous day. Is that right?
Right. We exactly, because we know the distance to them, so we divide the speed of light. We subtract that.
Yeah. Oh boy, this is going to get confusing. Okay. I mean, I don't know whether we have. I don't know. We should ask Jeff whether the data we have on planetary probes is. I mean, we certainly that data should exist to the minute. Probably to the second, actually.
Mhm.
Of course, then the correction depends on the actual distance to Mars, for example, at the time when if it was on the opposite side of the sun, it's going to be a longer delay.
Well, I can imagine that the dates they reported were already corrected. These things are typically corrected, but yeah, we would have to check.
Right. I mean, in
The same thing. The same thing happens, for example, with elevations. When elevations are reported on Earth or Mars or the Moon, etc., sometimes they subtract the geoid, sometimes they don't, and it's kind of messy.
well, wait a minute. I mean, that's like when George Everest decided that Mount Everest was the tallest mountain in the world, right? That is relative to the geoid, yes?
Exactly. Yes. But for example, the 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 elevations we report, because we have elevations for several planets. It turns out that in some of them they subtracted the geoid, in others they didn't.
What did they do with the other ones? They subtract a spherical planet?
No, they just measured from a sphere centered at the center of mass, but they don't measure the geoid and then subtract.
So
Probably,
wait, I don't understand. So like Olympus Mons, for example, its height is surely not equal to a radius vector of Mars.
no. But what they do is that they agree on a sphere, and then they just subtract that radius.
So they have a lame datum, basically.
Exactly.
That is a spherical datum.
Exactly. In the future, when they have much better measurements of the moon and they can measure a geoid, or perhaps they can already do it, they will subtract.
Well, I think the problem with the moon is it's not ellipsoidal, isn't it? I mean, it has this big lump in it, I think. I don't know.
Well, it's close to spherical, and that's why the spherical approximation is good. But still, the geoid, whatever it is, actually they will call it the selenoid because it's for the moon. It's a bumpy thing, and the good elevations should be always compared to the.
Yeah, that's a can of worms because we're not doing that for the Earth, right? For the Earth, the geoid is always an ellipsoid.
No. The geoid is a bumpy thing, and we have data for it. In the elevation data, you can say undulation, and you get the elevation with respect to the ellipsoid of the geoid.
Okay, but so why is it then that is it obvious that Mount Everest is the tallest mountain, so to speak, based on that whole discussion?
Yes, I mean the good elevations are those with respect to the geoid, the equipotential surface. It's what you feel when you are there locally, that it's the horizontal, right? It's the
I see what you're saying. I see. So it's based on the gravity vector
exactly,
at that point.
Exactly, the thing which is perpendicular to the vertical.
But when you're at the side of a mountain, right? Doesn't the mass of the mountain affect what the vertical is?
It does, and precisely that's why you have to be very careful with respect to which things you are measuring, because the right thing to measure with respect to is the geoid, the equipotential surface.
Fair enough. And so for for these weird shaped things that aren't spherical, like the moons of Mars or something, that's just a total can of worms.
Absolutely.
Okay, so
Because
nobody gets to quote the tallest mountain on Phobos or something.
Right. Water is important here because water will respect the geoid. You can have water flowing from some distance from a place to another place that have the same elevation with respect to the ellipsoid, but not with respect
to the geoid.
Exactly.
Fair enough, because the gravitational potential is different.
Exactly.
Yeah. Okay, fascinating. All right. Well, I think we've nailed the stuff for these date interval and so on designs, and sounds good.
Mm-hmm.
All right.
Right.
Okay.
Thanks, guys, and thanks
Great.
to the folks on the live stream. See
Okay.
you all later.